Hello students. Today we're going to determine the domain and range of this function right here. So we have a square root. That means we want positive values under the radical, under the square root symbol. But we also have a rational expression, so we cannot divide by 0. So that means that the square root of x minus 13 cannot equal 0. So that means that x minus 13 cannot equal 0. But moreover, because x minus 13 here is under this radical, we need x minus 13 to be greater than 0. Okay, well that's pretty simple. We just solve this inequality, and this is just a linear inequality, so this is pretty easy. And we need x bigger than 13. So if I just plot this on a simple 1D graph, there's 13. It would have to be an open circle, and I want everything to the right of 13 here, open circle. So in interval notation, the domain is simply 13 to plus infinity. All right, let's determine the range. Here's a plot of the function, and recall that the square root function is a positive number, so this function, if we look at this visually, this is going to be greater than 0, so that means that we can see that since the square root function is always bigger than 0, that's this expression here is the square root is bigger than 0. Could possibly be equal to 0, but because it's a rational expression, it will not be. So recall from the previous slide that this could not be equal to 0. So we have that this expression is bigger than 0, and 1 is always bigger than 0. And so that means that this thing is always bigger than 0. So that tells us that the range in interval notation is always bigger than 0. And you can see that. Here I'll try to trace out this. We have an asymptote here at 13. And then you can see that this function is taking a nosedive, and it's going to crawl very close to the x-axis, but will never cross the x-axis. So we have a vertical asymptote here at 13, and a horizontal asymptote, which is the line y equals 0, which is this line here. So that is the range.